Hello, and welcome to Train Signal. I'm Don Jones, and this is the Database Data Types lesson in the Database Administration Fundamentals course. In this lesson, we'll be talking about database data types. We'll talk about what data types are, how data types are stored within the database, and about SQL Server's data type conversion capabilities. Each column in a database table, whether it's a customer name or an order total or a date, doesn't matter. They all have a designated data type that you select when you design the table. And this data type indicates the type of data that the column will store. These are set when you create the table's design or schema. In some cases, they can be a little bit difficult to change once the table actually contains data. So this is something that has to be thought out ahead of time, well in advance, so that you can get the right data type for whatever type of data it is you plan to store. SQL Server includes a fairly large number of built-in data types, and programmers can create their own or user-defined data types. The built-in data types suffice for almost all applications, so seeing user-defined data types is actually pretty rare. SQL Server also distinguishes between CLR data types, which are data types from Microsoft's .NET Framework Common Language Runtime, and that's actually embedded in SQL Server. So we'll cover the built-in data types first. Starting with some of the more common built-in data types, you've got money, which is a numeric type that typically goes out to about 4 decimal places. There's datetime and datetime2. Datetime2 is smaller. It has less range, meaning it can't cover way back into the past or super far into the future, and it works in 1-minute increments. There's integer, which is a whole number, so a number with no fractional component or no decimal. The char type is a fixed length character. Varchar is a variable length character, and we'll talk about the difference between fixed length and variable length in just a moment. There's the Boolean type, which simply stores a true or false value, and a float, which is a floating point number, so a number that has a fractional or decimal component. Now, each of these different types of data takes a certain amount of storage space in the database. And obviously, you want to try and use as little storage space as possible so that you're being economical with your storage. So you tend to try and use the smallest data type that will accommodate whatever data it is you need to store. So the bit type, for example, stores a 0 or a 1. TinyInt only takes 1 byte, and that stores very, very small integers, basically in the range of 0 to 255, so very small numbers. Small int is 2 bytes, so it can store a larger number. You've also got int and big int, which take 4 and 8 bytes respectively, and can therefore store increasingly larger numeric values. The numeric and decimal types vary because you can specify how large of a decimal portion you want to be able to store, and so the more accuracy or the more numbers you keep, the larger the data takes on disk. Small money and money are actually both decimal data types. They're just sort of put there for your convenience. Small money takes 4 bytes and money takes 8 bytes. Date time takes 8 bytes. Small date time takes 4. A date, so that's just the date with no time component, takes 3 bytes. Time takes 5 bytes. I don't know why time and date together don't take up 5, 6, 7, 8. Yeah, they're exactly the same. I don't know why you would want to store them differently, except here's exactly why. If you don't need to keep track of the time component of something, let's say you want to keep track of an employee's start date, but you don't really care what time of day they started, you can save yourself 5 bytes by storing only the date, which takes up 3 bytes, rather than by storing the entire date time, which takes up 8 bytes. Date time offset takes up 10 bytes. Date time 2, that's that other one. That one varies. A SQL Server will try and make that take up less data if it's able to. Char, that's the fixed length character. You decide how large that is, so that's why that varies, as does varchar. And there's also something called varchar max, which is stored as a blob. And we'll talk in just a moment about what a blob is in SQL Server. Continuing with the data type list, we've also got nchar. Now that's a double byte character set storage. So all of the character fields or character data types that start with N are designed to store double byte character sets like Unicode. Those are useful if you need to store information in a non-English language that uses double byte character sets, meaning the language contains so many different characters that it needs 2 bytes. So each character in an nchar or nvarchar requires 2 bytes of storage on disk. You've got binary, which also varies, var binary, image, which is another one of these blob types, and a special type called unique identifier, which takes up 16 bytes. Some of the numeric data types are referred to as exact numeric data types. That includes int, which is your primary integer field. Use big int when needed. You really want to select the right size because you can't promote these to be bigger. In other words, if you design your database to use the int data type for a column, and you eventually need to store a larger number than int can accommodate, it's actually a little bit difficult to change that to a big int later. The bit type only stores 0, 1, or null. Now, SQL Server optimizes that storage because it doesn't actually need an entire byte. By definition, it only needs a bit. The decimal and numeric types are fixed precision and scale, meaning they have a predetermined amount of storage that they need to take up, which is why they're called an exact numeric data type. Money and small money are similar. Monetary currency values, those have a fixed amount. And you should refer to the SQL Server documentation for specifics on the storage requirements and, most importantly, the range capabilities of these data types. In other words, what types of numbers, what range of numbers they can physically store. There are also approximate numeric types, so this is different from exact, and these are used quite a bit less often in databases. They do offer more precision, meaning that they give you the ability to have more decimal places, and the 2 types that you'll look at here are real and float. In a lot of business applications, there's no need for 12 decimal place precision, although some databases, especially if you're working with scientific or engineering data, you might really need that precision, and that's why SQL Server provides these approximate numeric types. Then there are the date and time data types we discussed. Date, datetime, datetime2, datetime offset, small datetime, and time. These essentially just provide different possible date ranges and precision. So if you need millisecond precision or 1 minute precision, you're going to select the correct type based on that. These are stored internally in a very specific form. And that form is not always very human readable. So SQL Server offers a number of built-in functions to take that internal storage format and then present it in whatever form you want. So you could do month-day-year or day-month-year or whatever you needed for your particular purposes. A date-time offset is actually the same as a date time, but in addition to tracking the date and time, it also tracks the time zone offset from Universal Time Constant or Greenwich Mean Time. So if you have data that needs to be able to accommodate dates and times given to you in different time zones, then you might look at the date-time offset since it allows you to track the time zone that that date and time applies to. You should see the SQL Server documentation for specifics on each of these data types' specific ranges, precision, and capabilities. Getting to the character types, we start with those Unicode ones, that's nchar and nvarchar. Those are the ones that support the double byte character set, or DBCS capabilities. A char is a fixed length field. It's declared when you create the column, and this data is stored right within the row. So it's stored on the page with the rest of the data from the row. If you look at the bottom of this, you'll see that I have a char 10 declaration. So this creates a character field with 10 character positions. Now that is always going to take up 10 characters worth of storage, even if, in this case, I'm storing something that does not actually need all 10 fields. So the word Microsoft is only 9 letters long, but because I declared this as a char 10, I'm going to have that 10th blank space at the end. If I were to put the word Dawn in here, that would take up character positions 1, 2, and 3. 4, 5, 6, 7, 8, 9, and 10 would all be blank, essentially wasted space, which is why you need to use these fixed length types with, well, use some caution with them. Varchar, on the other hand, is variable length. You can store a string or characters up to the maximum declared value. Now what that means is when I create a varchar, I say, this is going to be a varchar 200. I can store up to 200 characters, but I don't have to store all 200. And if I don't use all 200, I'm not wasting space. These values are also stored right in the row. And then there's varchar max. This will store up to 8 kilobytes of text in the row or create a blob for larger chunks of text. So since that's the third or fourth time I've used the term blob, I should explain what it is. Blob stands for binary large object, and it simply means a chunk of data that doesn't fit within the 8 kilobyte page. So this is stored outside of the page on one or more successive pages. Skip right to the bottom of this where I've got the diagram. You can see that in the left-hand page, I've got my main row data. I've got a customer name, maybe it's employee name, I've got their phone number, and then I've got a photo, but that photo is going to take up way more space than will fit within this 8 kilobyte page. So instead, I'm not going to store the photo's binary data inside the page. I'm instead going to point to one or more successive pages that store that binary information. So the main row merely contains a pointer to the blob. This is good for blocks of text, image data, binary file data, and so on, but it's not the most efficient use of SQL Server in some instances. For example, if you wanted to store large file attachments like Microsoft Word or Excel files or something else, it might be easier to actually let those just sit on disk as files, because the file system is very good at storing files. And in the database, you might store the path to that file or a pointer to it, rather than trying to store all of that data in SQL Server itself. SQL Server actually has some advanced capabilities called FileStream, which can also help integrate that file system-based data, file attachments, with the data. Now, we're not going to cover file streams. They're definitely an advanced topic, but just be aware that there's a lot of different things SQL can do to help you deal with the storage of large objects. Sometimes the data that's in the database isn't quite in the data form or data type that you need, and so SQL Server will implicitly convert between certain data types. That means it's doing it transparently under the hood without you having to do anything. Implicit conversion does impose a performance penalty, so it's better if you store your data in the form that you intend to use it in, or if you use SQL Server functions to explicitly convert the data types when necessary. Here's a URL that offers a good explanation of this data conversion concept, along with some references to what SQL Server will and will not implicitly convert for you. SQL Server's two main explicit conversion functions are cast and convert. Convert's a bit more flexible, but cast is compliant with the sort of industry standards for the SQL language. The last two bullet points here will show you what this looks like. Cast something as int would take whatever was in something and try and turn it into an integer. On the convert example, convert an n varchar 10 something 101, and this would convert whatever was in something to a US style date of month/day/year. That's what that 101 is. So you really do wind up looking at the documentation a lot to look up the syntax and the different codes and numeric values that these functions utilize. In this lesson, we've talked about data types in databases. We talked about what data types are and some of the different ones that SQL Server supports. We talked about how they're stored on disk too, and how it's important to try and optimize your storage by selecting the smallest data type possible to store whatever data it is your database will contain. And we also talked about how SQL Server will convert between different data types when necessary, both implicitly behind the scenes and explicitly using the cast and convert functions.